So as we take a look here at the notes for sections 1.4 and 1.5, again, we're combining a few sections. You'll notice the table at the top here, just kind of, again, taking symbols, putting them into words, and what it means, okay? So you can kind of take a look at that table. None of that should be new to you. An equal sign, when you see the words is or is equal to, the same as, those are all things that indicate an equal sign. You have the less than sign, the less than or equal to, greater than, equal to. So take a peek at those kind of on your own. And again, if there's anything there that's confusing to you, then feel free to bring those questions and issues to class tomorrow, and we'll make sure we get those things straightened out. All right, so now we're going to kind of take those ideas and put them into practice now. All right, so it says write an equation or inequality, okay, based on the given phrases. So it says the sum of twice a number x and 3 is 11. Okay, so a couple key words. Sum, is, okay, and twice. Those are kind of the words that stick out to me. Now, the sum of twice a number x and 3. So that means I'm adding twice a number x and 3, so that's 2x plus 3 is 11. Okay? So again, when you see is, that means equal sign. All right? The quotient of a number n and 2 is at most 16. So quotient, dividing, at most is the next key phrase we're going to look at. So quotient of a number n and 2, that's n divided by 2, you can write that a few different ways, is at most 16. That means it could be 16, but it can't be more than 16. So if it can be 16 but no more than 16, that means it's got to be less than or equal to 16. All right, part C, a number q is at least 5 and less than 17. A number q is at least 5 and less than 17. Okay, so at the least it's 5. So that means it can be 5, okay, but it can't be any lower than 5. So we know that q has to be bigger than or equal to 5, but we also know that it has to be strictly less than 17. It cannot equal 17. All right, so that would be the inequality we're looking at there. And finally, part D says the sum of a number b and 3 is greater than 8 and less than 12. Okay? Greater than 8 and less than 12. So the first thing I'm going to do, I have sum of a number b and 3. So I'm going to start with that. So I have the sum. So b plus 3 is greater than 8 and less than 12. Okay? So it can be bigger than 8 and less than 12 all at the same time. All right. So again, those are fairly straightforward examples. Should be familiar to you, so hopefully there's nothing new there. My suggestion would be, as we go through this video, try the examples on your own first, and then kind of use the video here just as kind of a reference tool so that you can check to be sure that you're doing them correctly. All right? Okay. So the second part here, we're going to check whether numbers 3 and 4 are solutions to an equation. Okay? So all you're going to do is you are going to plug them in to the equation and see if it holds true. So for example, for the first one, you're going to do 5 times 3 minus 8 equals 8, and you're also going to look at 5 times 4 minus 8 equals 8. Now I don't have a ton of room here to work, so I'm going to be a little bit efficient here. So this guy here, 5 and 3, that's 15 minus 8. 15 minus 8, wrote 18, 15 minus 8 is not 8, it's 7, okay? So 3 is not a solution, okay? 4, let's see here, 5 and 4, that's 20, minus 8 is not 8 either. 20 minus 8 is 12, so no, neither one are solutions to the equation, okay? The next set of examples says decide whether 3 is a solution of the inequality. So again, same idea, you're going to plug in 3 anywhere you see x, or any other variable, and then you're just going to see if it's true. So for example, part A here, you're going to do 3 times 3 minus 2 greater than 5. 3 and 3 makes 9. 9 minus 2 is 7. So 7 greater than 5. That is a true statement, so yes. Okay. Part B, 3 plus 5 less than 8. 8 is less than 8. That is false. 8 is not less than 8. 8 is equal to 8. So that's no. That is not a solution. Part C, again, 3. So 3 minus 1 greater than or equal to 2. That's 2 greater than or equal to 2. That is true. Okay, 2 is greater than or equal to 2, so that's yes, it is a solution. And finally, I have 4 times 3 squared less than or equal to 32. 3 squared is 9, so I have 4 times 9 less than or equal to 32. I'm running out of room here. 9 and 4 makes 36 less than or equal to 32. That is not true, so this is not a solution. All right, so again, if you're asked if something is a solution, simply plug it in and see if everything holds true, okay, if you end up with a true statement. All right. As I look at example number 4 here, it says your scores on the last 3 tests were 82, 87, and 74. Your score on the next test is X points. Do the following values for X. Give you at least 320 points. Okay, so the first thing is you have to kind of conceptualize and set this thing up. So what you're doing is you're going to take 82, 82, 87, 74, and X is what you're doing. And for each of these, for part A, you're going to plug 75 in for X. Part B, you're going to plug in 81. Okay, so when I do that for part A, and at this time, you know, calculator is beneficial. You don't have to have one though. You should be able to do this mentally anyway. But 82, 87, plus 74, plus 75 gives me 318. So the answer to part A is no. And then part B, when I plug in 81, let's see here. When I plug in 81 instead of 75, I get 324. So this guy is yes. All right, so again, pretty straightforward. You just have to be able to understand what's going on and plug in for X. You have example 5 here. You have 2 part-time jobs. You earn $6 per hour running errands and $5 per hour walking dogs. You can work a total of 10 hours this weekend and hope to earn at least 55. Let R be the number of hours you spend running errands. Write an inequality that describes the situation. Your inequality should involve only one variable, R. Okay, only one variable R. So, as we go through here, you can work a total of 10 hours. Okay, and so what you have is this. You know that if you work R hours, okay, running errands, you make $6 per hour. So you have $6 times the number of hours that you run errands, okay, plus $5 times the number of hours that you spend walking dogs. Okay, how do you know how many hours you spend? Well, every hour you don't spend running errands, you're going to spend walking dogs. Okay, so you're going to represent that by saying 10, since that's the most hours you can work. Okay, minus the number of hours you spend running errands. Okay, and you want to earn at least 55, so we want that number to be greater than or equal to 55. Okay, so again, that's a little bit tougher there because you only have the one variable that we want to use, but nonetheless, hopefully as I talk through that, you understand that. Part B says, if you spend the same amount of time at each job, will you meet your goal? Okay, so in other words, if you spend the same amount of time at each job, you're going to work 5 hours of each. Okay, so 6 times 5 plus 5 times 5. Well, 6 times 5 is 30. 5 times 5 is 25. That would give you $55. The answer is yes, you would reach your goal. Can you reach your goal by meeting 10 hours, by working all 10 hours at only one job? Well, clearly, if you spend all 10 hours running errands, that's $6 an hour times 10, that's $60. So yeah, okay, the answer is yes, running errands, you'd be able to do that. Again, I know that I am going through these notes probably a little quick. Okay, but again, the idea is just to kind of give you an introduction and, you know, re-explain things in class as needed. Okay, so using a problem-solving plan. A lot of times I feel like students who are not proficient in mathematics, it's in large part due to the fact that they look at a problem and they don't really have a systematic way of going about doing it. So a problem-solving plan, first thing is read and understand what's going on, okay? Before you start writing down anything, read the entire problem and try to see the big picture. Okay. Then you start making a plan to decide on an approach to solving the problems. Sometimes you might want to start with a formula. Sometimes you might want to draw a picture. But create a plan. Have a big picture plan in your head. Step 3 is obviously execute that plan. Step 4 is double check your answer. Make sure your answer makes sense. Always. Okay. Always make sure your answer makes sense. Okay. So the next set here, this next table I should say, we're going to take a look at some formulas that are going to be used throughout these few sections here in solving some problems. Formula for temperature, C, let me get this right, there we go. C equals 5/9 parentheses F minus 32. Okay. F is degrees Fahrenheit. And C is degrees Celsius. Whoops. Misspelled that. Okay. And so that's how you go back and forth between temperatures. Simple interest. Okay. I equals P RT, where I is the interest. Let's see here. I is interest. P is principal. R is the interest rate as a decimal. And finally, T is the amount of time your investment is for. Okay. As we look at distance traveled, again, these are all right in your book, so you could look at this. It's D equals RT. D is distance. Okay. R is rate. And T is time. Okay. Again, I apologize for my poor handwriting. Hopefully, you're not having to read that. You can just kind of go off of what I'm saying. And then finally, profit is P equals I minus E, where P is the profit, I is the income, and E is the expenses. All right, so we're going to we'll use those formulas just to kind of carry out some plans. Again, just pause the video if you need to copy that down, but I'm going to move forward just for time's sake here in the video. It says you are designing the layout for a newspaper about teen issues. The newspaper will be 22.5 inches wide. You plan to have 5 columns with 1/8 inch gaps between them and 3/8 inch margins on the left and right sides. How wide will each column be? Okay. So again, it's 22.5 inches wide. So big picture, right? And this is where I would draw a picture. Okay, you don't always have to draw a picture. There are some problems where it's beneficial, others where it's not. So I would draw the entire newspaper first. Okay, so there's my newspaper. I know the whole width is 22.5. Okay, I know there's 3/8 inch margins on both sides. So I know when I do this and this is 3/8 and this is 3/8. Okay, I also know that there's 1/8 inch gaps between each margin. Okay, so now I have a margin, or each column I should say. So I have a column here. 1, there's a gap. Then another column. 2, then a gap. And then 3, and a gap. 4, and a gap. 5. And that's the last one, okay? So what I'm going to do is I'm going to kind of color these guys in just so that it's easier to see what's going on here. So the colored in guys are the columns. Okay, I know they're not the straightest things, but I just want you to be able to see the columns and the gaps and kind of see big picture, okay? Okay, it's not perfect, but it'll do. So again, you'll notice each one of these little gaps here, 1, 2, 3, 4, are all 1/8 of an inch. So the question is, how wide will each column be? Okay, so here's what you know. You know you have 22. Okay, so big picture, have a plan. Okay, you start with 22.5 inches. Okay, you subtract 3/8 of an inch from one side and 3/8 of an inch from another side. Okay, you also have 1, 2, 3, 4 1/8 inch gaps between each column. Okay, 4 1/8 inch gaps means there's 4/8 of an inch total. Okay, and then whatever this number is, so I'm going to go ahead, at this point it would be nice to have a calculator, so I'm going to do 22.5 minus 3/8 minus 3/8 minus 1/2 or 4/8, and I get 21.25 inches. That's how much room I have for my columns. Okay, so I got to take that. I have 5 columns, so I divide that number by 5, and that tells me that each column is going to be 4.25 inches. All right, so again, that's a tough problem. It's not easy. Okay, there's quite a bit of work to be done, but the idea is have a plan. Draw a picture if you need to, if you think it'll help you, and then execute your plan.